All right, we're going to take a look at another example here. This is day 2 of section 6.4, partial fraction decomposition. And this one is going to look a little different than what we did yesterday. So as you take a peek, this factor is still 6x plus 5 over, this time x plus 2, that quantity squared. Now you'll notice this is a linear factor, but it's squared, and so it's what we call a repeated linear factor. If I do this problem, I'm going to write a over x plus 2 plus b, and this time what's different than what we did yesterday, it's a linear factor but it's being repeated, so we write x plus 2, that whole quantity, squared. Now if I happen to have another one like x plus 2 to the third power, I'd have a over x plus 2 plus b over x plus 2 squared plus c over x plus 2 cubed. We'll see how this differs in something else in just a little bit. Now we're going to multiply this by its common denominator, which is x plus 2 quantity squared on both sides. I wish I could write a little faster. Alright, these two simplify here. And so I just have 6x plus 5 on this side. I have to move the screen a little bit here. There we go. Is equal to, now if I distribute, you'll notice that one of these x plus 2's simplifies with the one below. Otherwise, I'm left with a times x plus 2 here, and plus b, and you'll notice that the other parts simplify. And that's okay. It's just different than what we've done before. Now, what am I going to choose for an x? Well, I hope it's obvious to you that you're going to pick x equals -2. And when I do that, the left side becomes -12 plus 5 is -7 is equal to, this goes to 0, and I just get b. So that's pretty nice. I already know that b is -7. I don't have to work any harder. And now I can take a look at that and say, well, let's go ahead and substitute that value back in and see what I get. So over here I've got 6x plus 5 equals, because I don't have another x value to pick that's going to work very nice. Let's come over here and I've got a times quantity x plus 5. Excuse me, let me back that up. X plus 2, and sorry, and then plus -7. So my first step here would be to add 7 to both sides, and I get 6x plus 12 equals a times x plus 2. I'm not necessarily going to divide both sides by x plus 2, but you'll notice here if I factored out an x plus 2, I'd have a 6 on the outside. And so I can recognize, of course, that a is equal to 6. So that's pretty cool. Alright, so now I have my a and my b. I'm going to go ahead and substitute them back in and see my solution. I'll let you do that on your own to keep this video just a little bit shorter. Alright. So let's move on to the next example, which is a little more complex, and this is the idea I want to make sure that you see. If I do this particular problem, I'm going to recognize that this is equal to, if I do the factoring, I get x minus 6 on top, but I see on the denominator that this is going to be, they both have a 2x, and then I'm left with x squared plus 4. Okay. Well, that's a linear factor, but this, you'll notice, is not linear. It's a quadratic factor. I tried to factor it down a little bit more. If that was x squared minus 4, it would break into two factors, but this one is irreducible. So I'm done here. Now I'm going to write that as a over the linear factor, which is 2x. So here's the new idea, plus And since the denominator is not linear but a quadratic, I'm going to go ahead and write that down there. But on the top, instead of writing A, or next time would be B, I'm going to use this idea right here. If I have a quadratic on the bottom, the numerator is going to be linear. So I've got bx plus c. And this looks totally different, but it's really not that much. All right, so now I'm going to take this and say, well, I've got a common denominator, same idea we did before. So I'm going to multiply by the common denominator. And to save time, it's just so slow writing this. I'm going to get x minus 6 here equals, and then if you notice I'm multiplying, and I'll go ahead and do this side, I guess. It's 2x times x plus squared plus 4. All right. If I multiply this out, I'm going to get the 2x's simplify here, and I get a times x squared plus 4. All right. Plus, and now if I distribute here, you notice the x squared plus 4 simplify, and I get bx plus c times what's left is the 2x. And what's different about using these with quadratic factors is we're actually going to now multiply all this out. Because, for example, I can't find an x value, at least a real number, that's going to make this expression go to 0. This one I can put 0 in, but that doesn't help me a ton. It helps me maybe find a, but that's about it. So what I'm going to do is expand the right side. So I get ax squared plus 4a plus, here I get bx squared plus 2cx. All right, all that equals x minus 6. All right, so what we want to do now is combine similar terms. So I see both of these are squared, x squared terms. I'm going to write that as a plus b times x squared. And then here I've got, oops, the x term is right here, plus 2cx. So I've got that one covered. And finally I write plus 4a. And all of that equals x minus 6. So what we do now is take a look and we locate the variables. Like here, I don't have an x squared term, right? So its coefficient must be 0. So I come up with a plus b equals 0. I leave a little blank because I'm going to have c's in here as well, right? Here, I notice that 2c is the coefficient of the x term, and 1 is the coefficient of the x term here. So I get 2c is equal to 1. And last, I have 4a is equal to negative 6. Well, that helps me. So I can just identify so now I recognize that c from here must equal 1/2. Right? Here, 4a equals negative 6, which means that a is negative 3/2. And then I put it up here. The only way that's going to work is if b, I'll write it right here, is equal to a positive 3/2. All right. So now we can simply write our answer from what I've got right up here. So it looks, let me extend this page a little bit. There we go. So now I'm going to write that as my original, and I usually like to write it, but it takes so long to write with this. A is negative 3/2, so I write negative 3 over 2 times 2x plus bx plus c. So here's our b, 3/2 x, plus c is the 1/2, all over x squared plus 4. And now we're back to that whole fraction thing, but fortunately for us here, we recognize they both have a half, and so we can put that down on the bottom. So if I clean it up a little bit, it looks like this: negative 3 over 4x plus the 3x plus 1 over 2 times x squared. If I distribute, plus 8. And there we have it. All right. I think that's about it. I've got another video, a Patrick JMT video I'd like you to watch. The last example that I'm going to do in class that you're not going to see here takes quite some time. I'm not going to do a separate video. Just go ahead and look at the Patrick JMT one. All right. Thanks for watching. Have a good day.